Right, here we have the DOL starter. So the DOL starter consists of a three-phase circuit breaker. So a three-phase circuit breaker, when overcurrent is reached, you'll find that it'll break the red, the yellow, and the blue. So L1, L2, and L3 will be broken, and therefore no currents will flow to the motor. So the DOL starter has a three-phase circuit breaker. It also has a contactor and a thermal overload relay somewhere between the contactor and the three-phase motor. It has a start button to actuate the contactor, and it has a stop button to disengage the motor. So when the contactor is disengaged, the motor will then stop. So what the stop button does is breaks the live that goes all the way to the contactor. So if the contactor is no longer getting a live, it will not be able to be actuated, and so therefore the stop button breaks that. Okay, so let's look at the purpose of the motor starter. So the purpose of this motor starter, the DOL starter, is to limit the starting current and safely connect the motor to the three-phase supply without tripping the main circuit breaker and affecting other operations in the workshop. So the advantage of this DOL starter is that it's the cheapest and safest method of connecting an induction motor safely to the supply line. What does it contain? So the contents, the contactor is that part of the system which is an electromechanical switch that provides a safe and convenient means of connecting and disconnecting the circuit. It also contains a thermal overload relay. So normally the thermal overload relay will fit here, and the purpose of the overload protection relay is to protect the motor from serious damage, increasing the motor's operating life. Due to excessive currents drawn by the motor, the purpose of the overload relay is to prevent heating that leads to deterioration of the motor windings. These relays are used to control high temperatures. The overload disconnects the motor from the line when the motor experiences heating for a too long period, yet it allows overcurrents for harmless short periods. Right, here we're looking at the DOL starter schematic diagram on the right hand side. You can see this is your overload relay before the contactor button. Notice here it's called the keep in motor controller button. So when the start button is pushed, it's latched on, and so this way the contactor stays engaged. Only once I press the stop button will the currents stop from L1 going through here. So this is how the contactor no longer receives that current from L1, and so therefore the electromagnets will disengage and therefore breaking the contacts. So notice that switch that I was talking about will be this switch over here. So in other words, they're trying to say what happens if this switch is gone faulty over here. So the start button is pressed, you can let go the start button, and this switch here is now stuck once the motor is already connected. This means you won't be able to switch this motor off, because the contactor will be permanently engaged even after pressing the stop button, because it will be receiving L1, L2 and L3 from this direction coming down through the contactor to the motor. So as I said, the only way you'll be able to stop this motor is by giving the contactor a slight tap, and then it'll disengage, it'll jump out, holding down the stop button at the same time, and then giving it a little tap, and that's how you can disengage it. So also know the schematic diagram, very easy to draw. Normally they'll ask you questions regarding what happens if this is faulty, that faulty, so you have to use your common sense there. Right, next one we're looking at is the forward reverse starter. With the forward reverse starter, it's very much the same as the DOL starter. Now where would we use this type of motor system? So this type of system will be used where we have an elevator. You know, elevators go up and down, and therefore it will need a forward and a reverse starter. Motor starting, it's the same principle as the DOL starter. The only difference here is that you'll find at the bottom of the contactors, red goes to red, yellow goes to yellow, and blue goes to blue in the exact same order. But notice on the top you can see that they reversed two wires. So we got red going to red, we got yellow going to where the blue should be, and the blue now going to where the yellow should be. So how do we reverse the second contactor? All we have to do is swap any two phases. So sometimes as a theory question they'll say, how do you reverse the direction on a AC, three-phase AC? You will say, I will swap any two phases, and that's how we'll get a reversal of direction on the motor. Right, so notice here we also have a stop button and we have two start buttons, because one start button is for start forward, the other button is for start reverse. And so notice we can't just press the start button and then immediately press the other start button. So the system has to be built in such a way to prevent the bang. So remember, electricity, when things are not right, it goes bang. So the safety here will be an interlocking connection is built into the circuit to prevent the reverse starter button being pressed unless the stop button is pressed first, and vice versa. Right, here we have the schematic diagram of the forward reverse contactor. So forward reverse starter, we have the forward contactor being here, we have the reverse contactor being here. Notice the same difference about the same thing I was talking about, the swap around. We got, so notice how these three go here, right? And notice here now there's been a switch around. Okay, so notice now in the schematic they're now doing the switch around at the bottom, which won't make any difference, but yes, notice that it is switched around. Right, notice here with the forward reverse starter, same thing. They'll ask you about what happens if this switch is jammed. That means the motor will be stuck in a forward direction. If this switch is jammed here, it'll be stuck in a reverse direction. Same, they can ask you about the stop button. So you have to look at all the past papers with those questions. Look at the last 2 years past papers with those application questions. They practically don't get any different than that. Right, here we're looking at the three-phase sequence starter. This system prevents motor 2 from starting unless motor 1 has already started. Notice that this is the manual sequence starter because it doesn't have a timer. The timer circuit is not here. So this will be the manual sequence starter. So remember that at startup the currents are high, and the starting two motors at the same time can trip the overcurrent protection. So where are these motors used? These motors are used for hydraulic presses and for air condition units because it requires a two motor system where one starts and does one task and the second motor starts doing the second task after a predetermined amount of time. So normally with aircon units it will be an automatic starter because it's an automatic process. This now is like where you have two motors in a workshop and you cannot use the second motor until the first motor has started. So the reason for this is to prevent overcurrents from happening at startup. So start one motor as the spike drops in the demand for current, then the second motor can now start and run. So simple explanation, the start button is pressed. So when the start button is pressed, motor 1 will engage and already be running. The second motor, that is motor 2, will only be activated here. Can you see the switch here? It will only be activated once this motor is already starting. So what this switch does, it prevents this one from being switched on unless this system is already running. So when this system runs, the first motor is running, then only it allows the switch will close, then allowing this switch to run. So this switch is directly connected with this switch here, so that when this runs, after a certain amount of time, this one will also close, and then after a certain amount of time that you want to wait manually, you will then switch on this one. Okay, so that's what we are trying to say. So once again, in simple explanation, start button is pressed. So the start button is pressed, the motor 1 will run. Now at any time after this, you can now press the switch to allow the second motor to run. Why? Because the first motor is already running. So alright, then we have the schematic of the sequence starter. So most times they'll give you this picture and then they'll say identify or something like that. Identify the motor. Notice it won't be automatic because there's no timer here. So this will be a manual sequence starter, and that will be the schematic for it. This is the sequence starter motor with a timer. Notice the circuit is exactly the same as the previous one, except that it has this addition down the center here with the timer. Okay, so remember that the startup currents are high, and that's why the two motors are not really allowed to start at the same time. But also with some applications like an air conditioner, there's a purpose why one motor starts first and then the other. But the reason for the timer now is that it's automatic. So when the first start button is pushed, the first motor will run. After a predetermined amount of time, the timer will then actuate the circuit, closing the switch, engaging the second motor contactor, and that's how the second motor will start running. Okay, so notice here it has to be after a predetermined amount of time, the timer will actuate the second motor, engaging it. Okay, so that's how the automatic. So this means that this switch here is directly connected with the timer. So as soon as the timer, after it's what we call an on delay. So after that on delay is reached, you'll find the second motor will automatically start running. Okay, and that's the difference. Notice the faults over here. They might say, what happens if the time is faulty? So if the time is faulty, then surely the second motor won't start. So if the motor is already running and the time is faulty, then the second motor won't start. Questions like that. They might say, what happens if maybe this start button is faulty? Then obviously you won't be able to start the system. And also, as I discussed earlier, it's the same ideas over and over. Right, the next one we're looking at is the three-phase automatic star delta starter. So notice here it also has a motor with 3 contactors, so K3, K2 and K1. And so you have to just basically explain how this thing works. So first of all, you need to know the difference between which is star and which is delta. Right, so here we're looking at the star and delta connections. So which one would be the star and which one would be the delta? So remember, with star you got your connections going to your motor, so all you have to do is put what do you call it, the tags going across. So you find these little metal circles that connect across. So you got little metal strips with holes in it, so you connect them across, and this will be a star connection. A delta connection on your motor terminals will connect straight down. Notice that delta is a series connection, so it goes from from W2 to U1, from U1 to U2, from U2 to V1, from V1 to V2, to W1 back to W2. So you can see that that is series connection, whereas the star is more like a parallel connection. Notice here which one will be the star and which one will be the delta. So notice here, this will be the star connection. So if you look at here, remember the thing on top there, that will be your star connection, and this will be your delta connection. So you have to practically just know how the star delta works. So the purpose of it is to first switch the motor from a star to a delta connection. So when the motor first starts, you will find that it will be running in star connection, and after a while it will then connect to a delta connection. Notice that this will be automatic, hence the name automatic star delta connection. Okay, so we're looking at the three-phase star delta starter. So notice here, during the run, two contactors are closed. This will be the main and the delta. So you need to identify, how would you know the difference between the delta and the star? So remember, we said that the star got the straight line on top. So K1 is your star, K2 is your delta, and K3 is your main. So during the run, two contactors are closed. This will be the main and the delta. So K3 and K2 will be during the run cycle. So this is when the motor has reached its full operation speed. But at startup, the starter contactor and the main contactor will be closed during starting. So when the start button is pressed, the main and the star are closed, but after a predetermined amount of time, according to the timer setting, the star connector, the star contactor is opened. So the star contactor will be opened and the delta contactor then closes. So once again, when the start button is pressed, the main and the star, so the main and the star is closed. After a predetermined timer setting, you find that the star contactor is opened and the delta contactor then closes. So the delta contactor will close after the timer has a predetermined time. So notice here on the sign on the side here, they're showing you the timer, and after a predetermined amount of time, the star will open and the delta will close. So why do we need the system? Because more torque is applied to the motor in a delta mode. So in a delta mode, there'll be more torque going to the motor when the motor is running. But at startup, we need the star system just to safely connect the motor into running. And once it starts running, then the delta now takes off. Right, so we got different states here with this automatic star delta starter. Different states. So we have the off state. In the off state, all three of the contactors are open. Then we have the star state. During the star state, we have the star contactor and the main contactor being closed. Then we have the open state, where the main contactor is closed but the delta contactor is open. So at this stage there's no current flowing. And then we have the delta state, where the main and the delta contactor is closed and the star is open. So yes, it can seem somewhat confusing, but you just have to practice those lines of thinking. How you will identify this star delta starter, look for this, and how you'll know it's automatic, it'll have a time of year. So they'll ask questions also, what happens if the switch is jammed and stuff like that, the switch is faulty. You have to use the same type of reasoning. Okay, and that is it.